Hello, everyone, and thank you for joining us today. I will be giving you my presentation on what inquiry-based learning looks like in a high school chemistry classroom. This is the final project for the EdCI 6610 course. A brief overview of what you can expect in this presentation. I'll begin with going over the demographics of the school that I work at, the student composite, the challenges that I could potentially encounter, a breakdown of the standards and the learning target and goals that I have for my students, prerequisites, background knowledge, as well as a calendar for the lesson implementation. I'll be showing you my lesson plan, lesson resources, how I proceeded with the presentation of the lesson and the samples of the work that my students completed. To begin, the reason why I selected this specific chemistry class is because I have all of the grades in that specific period. This is my smallest period with 23 students total. 5 of them are freshmen, 14 are sophomores, 3 are juniors, and 1 is a senior. A little bit of our socioeconomic status, everybody. 90% of the student population are Spanish speakers, with Spanish being their first language. They're categorized as ELLs. We also have 1% of the students in our campus coming from an English-only household, and the other 1% is also an English language learner, but this time they either speak Chinese, Japanese, Korean, or Vietnamese. In terms of breakfast, all of our students receive free breakfast, and some receive either free or reduced cost lunch. Before I begin this lesson, I asked the students how much science background they had in the specific topic of physical and chemical changes. And many told me that they had very little, but what caught my attention is many told me that they had no lab exposure in their middle school. That's coming from the freshmen. And that worries me because these students, if they are taking chemistry, that's because they have a strong lab background. When it comes to my 10 to 12th grade students, they all need to have taken at least biology before enrolling into chemistry. So my freshmen had not even taken biology in their middle school. The characteristics of a struggling student, in other words, what I noticed uh, could potentially get in a student's way is having very little to no support at home, having very poor math skills, afraid or nervous of participating in class, constantly being reminded as to what assignments they need to complete in the course. When working in teams, they're not engaged or they contribute very little. They prioritize extracurricular activities and don't make up missed assignments. So that's for the struggling student in chemistry. For the struggling classroom in chemistry is the students have very little to no lab skills. They have less than 10 labs of experience, either in their middle school science or biology courses. They have very poor math skills or have not been successful on passing Algebra 1. They rarely ask questions or do not participate in the class interventions. They do not know how to read a text. They have very poor note-taking skills, and they rarely show up to interventions during the advisory periods or the after-school session. For this lesson, I focused on two standards, which is High School Physical Science Standard 1-1 and 1-3. First one is constructing and revising an explanation for the outcome of a simple chemical reaction. And the second one is conducting an investigation to gather evidence to compare the structure of substances to infer their electrical strength of forces between particles. In other words, the students need to see a chemical reaction and they need to be able to explain, are you seeing a physical change or are you seeing a chemical change? That's typically what these two standards are assessing. What characteristics make a change a physical change and what characteristics make a chemical change chemical change? The learning targets, the students can identify and describe the differences between physical properties and chemical properties, as well as physical changes and chemical changes. The way that I'll be assessing that is when students do a lab, which they will be burning magnesium with oxygen and seeing it combust. The goals that I have is they can work in a team. They will practice their speaking, listening, and writing skills. They will demonstrate the use of proper lab equipment and writing in complete sentences, evidence statement to support their understanding of physical changes, chemical changes, and physical properties. The goals at the bottom, the students have already been shown how to use lab equipment, so they know how to handle the equipment. They have also been practicing their collaboration skills. So my goal now is, can they actually apply them in a lab setting? Prerequisites. The students need to be familiarized with Google Slides. They will be participating in a slide deck that they will be completing throughout these 4 days of the lesson. They need to be familiarized with the properly handling of a Bunsen burner, basic annotating strategies such as highlighting or underlining, and how to read a periodic table. Once again, that's something that the students have been practicing since September of our school year. They needed to have known how to use the Bunsen burner, the names of the basic elements in the periodic table, lab safety protocols, and they can refer to their notes as their main source for information. And the breakdown, which what I explained to you was, is the students need to be able to look at a reaction and see if it's a physical change or a chemical change, and understand the attractive forces that are involved in a physical change and a chemical change. The calendar, I decided to divide it into 4 days. There are 4 topics: physical properties, physical changes, chemical properties, and chemical changes. So I wanted to focus on one day at a time. This way, it allows me to see what the students understand, but also it allows me to offer the students an opportunity to engage with the Google Slides, typing up their answers, and me selecting the students to participate in the class discussion. So the first day, it's learning about physical properties. The second day, it's physical changes. The third day, it's chemical properties, and the fourth day is chemical changes. That fourth day is also when they are going to be doing their lab and submitting their slide, where I'll be assessing what they understood. Let me show you what my lesson plan looked like, so that you can see what I was giving to the students. So this is my lesson plan. And I have the standards, the targets, the goals, and my lesson plan consists of various activities where the students are typing their response in their slide set. I rolled the dice to select the students that are going to be participating there, that are going to be sharing their answers. I also have guiding questions for the students to answer, primarily because my students, I noticed they had very little understanding of how to read a science textbook. So I needed to incorporate some guiding questions. As you can see, the focus is what the authors want you to know about physical properties. And as they were reading their textbook, these are the things that I wanted them to focus on, just so that they can get something meaningful out of it. I had the students do notes. I gave them the format. I gave them the models that they needed to include. I explained the models to the students. I constantly had them doing learning reflections in the form of a 3-2-1, so that the students could not only think of what they were going to type, but also be willing to share the answers with their classmates. And that was throughout the entirety of the lesson. Let me show you what those slides look like, so that you can get an idea as to what to expect from those slides. I began with a little bit of background information. The students type up what they understood. They heard what their classmates said, uh, what the authors want them to know about physical properties of matter, checking for understanding, 3-2-1, all of which are reflective activities, giving the opportunity to share with me what they understand. I also included three videos for students to watch specifically to help the students that struggle with reading comprehension. They might need that little bit of an extra help. So those three videos gives the students a visual representation of what these chemical properties look like. At the end of the lesson, these are the three slides that I'll be using, slides 9, 10, and 11, to see how much the students actually learned from the particular delivery of the lesson. The textbook that the students use, okay? I'm also going to be including this as a resource in case you want to incorporate this lesson with your students. Great way for students to engage themselves with the content. The authors do a great job at showing models, questions, pictures with explanations, asking the students to reflect on their learning, giving them images of what they might have experienced in their daily lives. So this is a great resource, and showing the students how to read a book, specifically science textbook, is also very, very helpful. And this is the lab that I gave the students, which is a physical and chemical changes lab, or the properties of magnesium. I did require that the students record a video of what the reaction looked like, because slides 10 on their slide deck has them insert a picture and provide a reasonable explanation as to why uh, the picture that they are submitting is either a physical change or a physical or a chemical change. Okay, so if we look at the, oh, by the way, on this slide, I have access to, I'm giving you access to all of the documents that you just saw on the presentation in case you want to implement it with your students. The way that I delivered the lesson was the following. I incorporated the students' background knowledge. The first two slides, slides 2 and 3, it's all about students' background. Tell me what you understand, type it, and after you hear it from your classmates, what did you understand from them? The lesson involved research. To me, research is give me a source that is trustworthy, in this case, their chemistry textbook, and they use their textbook to practice their annotating strategies, engaging in a group conversation with their lab team, with their partners. I myself guided the discussion by providing them topics to discuss. Once again, I showed you the types of questions that I was asking the students just to have them focus on that specific topic. Google Slides, which once again, that is possibly one of the best resources that we as educators have if we want to get all of our students engaged in conversation within, or I should say after the COVID era. You know, the best way to get data from the students is give them something to type, and you can see what they are typing on the other end. My freshmen, I noticed they were a little bit timid in getting asked or getting their name selected by the dice. But when it came to the juniors and the seniors, they were doing just phenomenal. There was some direct instruction needed, specifically when I noticed that the students had no idea about attractive forces and how to write chemical formulas. And lastly, when it came to the lab, the students really liked how the magnesium reacted with the oxygen. And students typically, when it comes to labs, they tend to do good overall. What I did notice, some of the key findings where the students were engaged and they were actually participating when they were asked to type their responses in Google Slides. I mean, I rarely saw a student having difficulty as to what to type. The only difficulty was whenever they couldn't get their Chromebook to turn on, but they were very willing to type up their responses. Secondly, having one topic per day made a huge difference, especially for my students that have special needs or that needed that extra time to process something. It it gave them time to focus on that one topic, but also time to think of what answers to type. And lastly, a quick survey at the end of the lab. The students agreed that the lab gave them exposure to chemical and physical changes Especially, they mentioned that they liked the incorporation of the three videos as part of the Google Slides because it gave them a visual representation of what to look for in the magnesium lab. The recommendations that I have is allowing the students to work with a partner or with their lab team. It's okay to allow the students to work as a team as long as the students are completing meaningful work. Have a system in place where student selection is randomized. In this case, I was rolling a dice, and the students mentioned that this was fun because they did not know who was going to be selected to share their responses. And lastly, just to keep student accountability, is walk around to read what they are typing or open up GoGuardian or a similar service. Our school has access to GoGuardian, so I can just log into my account and see what the students are typing. This way, when a student asks you if what they're typing is accurate or correct, you can tell them, you know what, focus on this or remove this, or you might want to look at your notes, or you might want to look at the video that you recorded. Now, let me end the lesson by showing you the, oh, first, let me show you the sources where I got my standards from. I got it from the Next Generation Science website, and the answers for the work that the students included as part of the answers were these. So these three slides are coming from a freshman. I'll give you time to that, or you can pause the video to read their response. But overall, I was very satisfied with their overall responses for the chemical properties of matter. Here, they took great pictures of what happens during the combustion of magnesium, the before, the during, and the after. I'm pretty sure that if I asked the students to describe what they saw, they would be able to tell me. And the learning reflection, what they learned. Especially what I like about these answers is how they're using their own understanding. My sophomore is a little bit more organized as they pretty much numbered everything, the three things that they learned about chemical changes, the two questions that they have, and the one example which they related to the digestion process. My sophomore also included pictures, but not only that, they also included a description of what happens in a chemical change or a physical change. My junior, on the other hand, I don't know if my junior was rushed, but my junior did not include pictures. However, what saves my junior is that they included enough description in their responses that leaves me satisfied with what they saw. This student even mentions that magnesium and oxygen, when combined, they create magnesium oxide in a brittle form. So I mean, the students taking the time to investigate what chemical product is being produced, that makes me very happy. And my senior, I mean, if you read the responses that my senior typed, I mean, you can tell that she spent some time doing research because she's talking about the forming and breaking of chemical bonds, the formation of a precipitate, production of gas bubbles. Uh, they're talking about the burning of wood in Christmas, carbon dioxide. I mean, they incorporate a lot of information to demonstrate that they have a solid understanding. Same thing, my senior forgot to include a description, but if you look at the learning reflection, also the learning reflection is written in their own words. Okay. So that was my presentation. If you have any questions, hey, you are more than welcome to reach out, and I'll be more than happy to help you. Thank you. Bye-bye.